Good afternoon, everyone, and welcome to this special session on fast fashion measurement of clothing prices using alternative data sources. So I'd like to welcome you. My name is Chris Jenkins. I'm the chair of the session. I work on inflation statistics at the Office for National Statistics. We've got three presentations today. We've got Greenhough from the Office for National Statistics. We've got Heidi Ertl from Statistics Canada, and we've got Claude Lamboray from Eurostat. So I'd like to thank them for joining us today as well. I'm just going to quickly run through the flow of the session today. So all presenters are going to have roughly 20 minutes to present, and then we'll follow that up with a 5 to 10 minute question and answer. During the question and answer, if you have a question, or if you have a question that comes up during the presentations, can you please use the question and answer facility at the bottom of the screen to submit your questions. And then when we get to the Q&A part of the session, we'll invite those who have asked questions to kind of ask their question. We will unmute your microphone in advance of that. If you are going to ask a question, please can you introduce yourself by stating your name and your affiliation. And I'd just like to point out that the session will be recorded. So in terms of timing, the session is going to run to 3 o'clock. The session will automatically end, so timekeeping will be important. So we apologise in advance if we can't actually get through every question that might be asked. But please feel free, if you don't get to ask your question, to email the question through and we can deal with that after the session. So I'm just going to give a very quick introduction presentation. There are some common concepts and definitions that are going to come up during each of the presentations. So if I just give a very quick introduction, and then I'll hand over to the first presentation, which is Liam. Okay, so during the session today, there's going to be quite a few common concepts. I'm just going to run through them. So the first is a product offer. So a product offer is just essentially the thing that we observe the price for. It's a product specified by its characteristics, the timing, the place of purchase, and the terms of the supply. And then we've got a homogeneous product, which is a set of product offers, amongst which there are no significant quality differences, and for which an average price can be easily calculated. Then we've got what we call an elementary aggregate. This is the lowest level of aggregation that we typically use in price indices. And then we've got an elementary index. So the elementary index is the index for the elementary aggregate, or a stratum that's within that elementary aggregate. So we're going to talk about hierarchies. So a hierarchy is just a structure that defines how product offers are classified to higher level aggregates. So for each item, we select the group of product offers and we track that over the year. Each item is an aggregate, but is also a subset of higher level aggregates. So we've got an example here of the classification structure we use in the UK, which is the ESCoE classification. And you can see we've got items at the bottom of the family tree or the hierarchy, and then that gets aggregated up through the various classes in the hierarchy. So we're going to talk about traditional measurement. So this is effectively how we measure price indices at the moment. And we typically measure them using what we call the fixed basket approach. So each year we select a basket of product offers to track the price over a year. And at the start of the year, that basket is refreshed with new items to account for how consumers change their behavior. So the example we've got on the screen at the moment is in 2019, we replaced a crockery set in the basket with just an individual plate, because that better represented how consumers were spending their money and their purchases. So we've then got what we call traditional collection. This is typically how we collect prices for consumer price inflation at the moment. So each month we go out and we collect hundreds of thousands of prices, and we do it locally. When we say locally, that means we send out price collectors into the field and they collect prices from shops. And then we do what we call a central collection, and that is where the collection is carried out by the National Statistics Institute typically, and that's done within the office using the phone and using the internet. So then we've got aggregation, and this is just simply we collect hundreds of thousands of prices. Aggregation is the way that we combine these prices to give us price indices at higher levels. We don't want to know what the individual price of every single product is. We want to know what the price is at a more aggregate level. At the lowest level, we use elementary and weighted index formulae, the most common being Jenkins. And then as we move up through the hierarchy, we use weights to combine our indices to give us more representative price indices at the higher level. So one of the main concepts today will be alternative data. This is simply the new data sources that we're looking to use in the measurement of consumer prices. And there are two typical versions of that. So we've got scanner data. So this is electronic point of sale data. Every time we go to a retailer, a big retailer, we put our products through the scanner, and that information is stored, and then we use that to collect or to compile our price indices. And then we've got web scrape data. So this is simply where we access the online platforms for each of the retailers, and we take their price data from those platforms. A key point, though, is that with alternative data, we're going to use this in conjunction with the traditional collection. We can't use alternative data for the whole CPI basket. So this slide just gives a few of the pros and cons of the various methods of price collection. I think when you look at scanner data, one of the biggest benefits of scanner data is that you actually get quantity information. So we know how much is being sold as well as the price data. And then you can see that when we move to scanner data and web scrape data, we're actually getting prices daily. So we're considerably increasing the number of price data that's available for us in use to calculate our price indices. So given today is about clothing, I just want to quickly touch on some of the problems with clothing. So the first one is what we call product churn. With clothing, it's difficult to track the same product over time because clothing changes so frequently. And when products are changing frequently, that introduces the issue around quality adjustment. So in price indices, we're looking to compare comparable products over time. How do you do that when ranges are changing so quickly? We then got seasonality within the clothing sector. Retailers tend to refresh their stock at the end of the season and bring in new stock. So seasonality will give us issues. And ultimately with prices in the clothing sector, there are lots of sales because at the end of the season, we see that retailers are trying to sell off the stock that's out of season as they bring in the new season's clothing. So that's a very quick introduction to some of the concepts. We've got Liam, who's going to speak next to give us his presentation on research into using alternative data sources in consumer prices. We'll then hand over to Heidi Ertl from Statistics Canada, who's going to talk about the implementation of alternative data sources in production. And then finally, we'll hand over to Claude Lamboray from Eurostat to tell us about integration of new data sources alongside traditional collection. So I'm going to stop sharing and ask Liam if he will please start sharing and give his presentation.
Okay, hi all. So I'm Liam from the Office for National Statistics. I'm going to cover the kind of UK perspective of some of the research we've been doing into using alternative data sources in consumer price statistics. So as a way of introduction, I'll start with a kind of timeline of our implementation. So in 2020, we're focusing on specifically research. So I like to think of it as kind of building up a kind of suite of methods that we can use with alternative data sources. So this includes, for example, classification methods, outlier detection methods, index formula methods, etc. The idea is that we build up a suite of methods of many different alternatives based around case studies. And then looking into 2021, once we've got all these kind of different methods, we can start applying them to a much wider range of the kind of data sets that we are collecting. In both 2020 and 2021, we are developing a statistical pipeline. So a lot of these kind of data sets are a lot bigger than, I guess, our traditional data sets, sometimes upwards of hundreds of millions of records long. So we need to make sure that it kind of works because you've got a lot of traditional problems such as a lack of memory to process that kind of level of data. So we need to make sure we can optimize our system so that we can run these kind of methods quite fast. Looking into 2022, we'll kind of enhance our engagement, I guess. We're already engaging with we've got an advisory panel which we can speak with our stakeholders with to engage with. But in 2022, we'll enhance our engagement and conduct a parallel run with the idea of having, for example, quarterly publications ahead of our launch date in 2023. So in 2023, we're aiming to launch with a particular set of priority areas, but then beyond 2023, we'd look to integrate alternative data sources for extra areas. So some of the priority areas that we're covering ahead of 2023 are given on this slide. So it includes, for example, clothing, groceries, tech goods, used cars, airfares, package holidays, chart items. So chart items are things like books, DVDs, Blu-rays, etc., and rail fares. So like the reason we've chosen these kind of these areas have been based around things like data availability, the impact it can have, but also some of the kind of methodological challenges we've had with traditional data. And these areas have been prioritized with our stakeholders. As I mentioned, we're building a statistical pipeline and a very brief pipeline, as I've given on the right. So it includes modules such as classification, product grouping, outlier detection, averaging, imputation, and the index method. I've excluded some steps such as pre-processing pack size standardization, just viewing them as out of scope for today. Like I say, we're building the pipeline in PySpark, which allows us to perform cloud computing in order to process data sets that would not traditionally fit in memory. So the focus for today is going to be classification, product grouping, and the index method. Classification is, for example, you take a clothing data set and you split it down into things like jeans, dresses, sports bottoms, etc. The product grouping I'll come on to at the end because I need to explain that a bit further. Averaging would be kind of if you scrape a price, a product maybe 5 times in a month, you take an average of those prices in order to obtain a representative price for that product offer. And finally, the index method is the formula you're going to use to produce your indices. We'll start with classification. So one of the challenges with our clothing data set is just how big it is. So we're collecting around 500,000 to 750,000 unique products every month. And we would not be able to individually assign a class to every single one of those products. It would just take too long. So we're looking at supervised machine learning methods to do this. And the idea is you build a kind of a model based on a sample of the data, and then you use that model to provide predictions on the kind of data that you've not sampled. And that's the way we can kind of classify the entire data set based on just a sample of labels. The kind of machine learning approach typically is to perform some labeling, so to go through a sample of products and assign a class manually, and then train a model, which if you've done regression before, it's very similar. So you've got a set of independent variables and a dependent variable, and you're going to build a link between the two using an algorithm. And then once you've kind of trained your algorithm to learn those rules, you then apply it to that to the new data. As the starting point, we need to decide which classes we're actually going to classify to. And there's a bit of a trade-off here. So at higher levels, for example, sportswear is generally going to be a bit easier to classify towards because like the decision rules that you need to learn are going to be a bit more simpler. So for example, sportswear, there might be a sportswear section of a website, in which case the rule is very simple. You just need to identify that the product location contains sportswear. So generally, the more you break it down, the more difficult it's going to be to classify. But it also gives you more homogeneous kind of areas. So what I mean by that is, like, for example, with sportswear, you might have a £5 base layer bottoms and a £300 ski jacket contained within that sportswear class. Whereas if you break it down to that kind of the more granular levels, then you get kind of much more kind of distinct kind of products within that class, and that's desirable when you're building in your index methods. So then once we've kind of decided our classes, so what I should say is we're kind of labeling to multiple different levels, and we're kind of testing how well we can kind of build a classifier to predict the lowest level classes, and if we cannot predict that level, then we might look upwards at a higher level class. But to kind of produce that kind of labeled data set for us to build that machine learning algorithm, we need to first do some labeling. So we're doing this in-house as part of the prices division, and we're labeling around 9,000 products per month using a Python application we've developed in-house. We use this algorithm, application that is shown on the right to label our data. But there is some subjectivity in our labeling. So, for example, this is a real product. We've got a fleece zip-through jacket. You might label it as a fleece, a jacket, or maybe like a fleece-lined waterproof jacket. So there's maybe some inconsistency in how labelers would label that. We'd run an experiment, and we estimate that labelers are around 89% consistent with one another, but the details of how we've gone around that experiment will be given in a link that I'll share later. Once we've obtained the label data, we then need to split the data into a training set and a test set. So we'll train the algorithm on the training set and then test the performance of the algorithm on the test set. And this is a graph showing the performance of our different classes. So each point represents an individual class. The x-axis represents the training set size, so the amount of data that we've trained that class on. The y-axis represents a metric of performance. So it represents precision. So as an example, an 80% precision would mean that 80% of the products that have been classified to that class are actually from that class. And what you can see is that generally, as the training set size increases, the performance also increases, which might be expected. You're training on more data, so you should get higher performance. But it's not a really strongly linear relationship. There is quite a spread in terms of how the classes are spread out, I guess. And this can be typified by the orange classes. So in the top left orange class, you've got girls' swimwear. And that's generally quite easy to classify to, because you've grouped together all swimwear into one class, and therefore you just need to work out some like really simple decision rules, such as that it's in the swimwear section, it contains something like swimsuit in the product name, or swimwear in the product name, or swim, for example. So the kind of decision rules are quite simple. If you were to break that class down, as we suggested we might as we obtain more label data, if you break that class down, then the complexity of the task is increased. So, for example, if you break that swimwear class down into caftans, rash vests, swimsuits, swim sets, etc., then you've got less training sample per class, and the complexity of the task increases, so we'd expect that performance would drop. And also, like on the other side of things, you've got the orange class in the bottom right, so that's babies' outfit sets, and that's quite a difficult class to classify to, because you've got so many different types of sets. So you could have like a leggings and a t-shirt set, or you might have a trousers and sweatshirt set. Like there's not a kind of unifying set of terms that would allow you to classify all the products in that kind of class. So the classification task becomes much more complex. So I'll now talk a bit about our index methods. So we're covering, so we want to work out which index methods work well with our different, with our alternative data sources. And there's two sets of methods that we're particularly looking at, bilateral and multilateral indices. So bilateral index methods can be seen as comparing two time periods. So you've got a base month and a current month, and you've got fixed base and change variants of bilateral methods. And the difference between the two can be observed in the following animation. So a fixed base method keeps a constant base month, and the current month changes over time. A change method keeps the 2 months consecutive. And the trouble with the fixed base method is that, for example, with clothing, it's known as a high product churn market. So products enter and leave the market very fast. So the number of products that are available in the base month and a month in the future can quite diminish throughout the year. So by the time you get to December, you might only have like 10% of the products left. So then your kind of index is not as representative anymore. With a chained index, you keep the months consecutive, so it gets a bit around the product churn problem, but it can exacerbate a fall in the index, which I'll kind of show in a later slide, not with the chain method, but with a multilateral method, but the chain method certainly exacerbates the fall. With a multilateral method, you're using many months within a window. So that in this example, it's a 4-month window, but you're using many months in conjunction to build your index method. So we're assessing a lot of index methods. So currently I'm showing 8 different bilateral index methods, but they all have chained and fixed space variants. So that's a total of 16 bilateral methods. And we've got 6 multilateral methods, but each multilateral has to be paired with an extension method. And we've got 6 extension methods, so that means there's 36 different combinations of the two. So that gives 52 different index methods in total that we would like to assess. That's really challenging. Like it's the level of detail we want to go into in order to assess these index methods. It's going to be really challenging to assess all 52. So we've come up with an index framework to go about this process. So the first stage is to shortlist the methods. So we start with the 52 methods. We remove methods that do not meet a minimum set of requirements. So that drops out a few methods. And then we apply a theoretical framework to the remaining methods, which scores each method against various criteria. That leads us to a top 10 set of methods. And those top 10, we're then going to apply a range of synthetic data sets to that top 10. So the synthetic data sets may contain things like different kind of market characteristics, like a market which represents high price variability, or market that represents price obsolescence. So that's where, like, for example, with laptops, a product diminishes in price over time due to the fact that it's not competitive with other products emerging on the market. So we assess each data set again, each index method against the synthetic data sets, and we know then which index methods behave well under which data sets. So then when we come to our application phase next year, we can compare the kind of different areas that we are collecting against those synthetic data sets to see which index methods behave well. And that's how we can approach a index method that would be ideal for a given kind of type of product. So now I'm going to compare, going to use classification and the index method in conjunction. Before I do so, actually, I just want to point out that in our kind of index framework, the Gex-Jevons using movement splice, which I've highlighted here, which is ranked 4, is our highest scoring unweighted index method. The top 3 methods are all weighted, but because we have web scrape data for our clothing data, we need to use an unweighted method because we don't have weights associated with the web scrape data. The indices we're going to show experimental, don't truly reflect market behaviour. I'll come on to why we don't believe that to be the case. But instead, we're going to focus on the closeness of the indices in this section. So we've got 5 different classification algorithms: XGBoost, random forest, support vector machine, logistic regression, and the decision tree algorithm. And we've got 4 different clothing classes. So these are women's dresses, women's jeans, women's sports bottoms, and women's suit jacket. The F1 score is a measure of performance again on the test data set. And what you can see is there's 3 things to observe from this slide.
That's just under 5 minutes left, Tim.
Yeah, sure. So dresses is a high performing class, as is jeans. Sports bottoms and suit jackets are lower performing classes. The second thing to observe is that the 4 main classes, 4 main algorithms, which is XGBoost, random forest, support vector machine, and logistic regression, are similar performing, whereas decision tree is lower performing. So coming on to the indices now, we saw that dresses is a high performing classification class. And what you can see is the 4 main algorithms score similarly. They're really tight indices. Whereas with decision tree, with its lower performance, you can see it diverges a bit. Similar is true for genes. So the 4 main classes are really tight, whereas decision tree, it does co-move reasonably well, but you can see it's a bit different, like it's a bit further out from the other 4 classification algorithms. Whereas when you get onto the kind of lower performing classes, so that's sports bottoms and suit jacket, with sports bottoms, the indices now spread out owing to its lower classification performance. But you can see, again, there's some resilience to classification error because they co-move fairly reasonably well. But suit jacket is certainly a lot more kind of divergent, and that's largely due to low sample sizes for women's suit jackets. So just a few misclassifications can cause the indices to diverge quite largely, I guess. But one thing to, so what we've seen is, I guess, classification performance is quite important in producing indices that would be representative of the kind of index for that market. But what you can see is all four classes fall in terms of values. So dresses falls to 0.8, jeans to 0.9, sports bottoms to 0.95, and suit jacket to 0.82 to 0.92. So it's always falling. We don't believe that that's necessarily representative. The reason for that is, so this gets into product grouping now. What an index method is doing is it's tracking individual products over time. And because with clothing products, generally they come to the market at a high price and leave at a low price, generally the index is picking up the fall in each individual product. But there's a price reset when new products come into the market, but the index method, because it's comparing individual products, it's not capturing that resetting from a new product coming onto the market. In traditional data sources, we link products, so products that leave the market are paired with products entering the market, so then that kind of resetting process is captured traditionally, but that kind of process is very time consuming because you have to manually link and apply quality adjustments. We can't do that with the 500,000 to 750,000 products we're collecting. So instead we're looking at product grouping, and the idea is that you would create a cluster within a class, a set of clusters even, and you'd measure the change in the average price of the cluster rather than individual products. So this creates something known as homogeneous products. Now the old and new products are linked into the cluster, so the product churn problem goes away because you now have a set of clusters that are ever present. But the challenge is you need to make sure that the clusters are homogeneous, because the reason for that is, imagine you've got a cluster in month 1 which has lower quality on the whole, and then a cluster in the same cluster in month 2 which has higher quality. The index may raise due to the quality going up, but that's not measuring price change then, it's measuring a quality change. So what we need to make sure is that the cluster is homogeneous, it's of similar quality, so that it's measuring price change and not quality change. But that's a piece of ongoing research, so we don't have results to present today, but that is a part of our future work. So any questions? I've got a link to papers which will be available in the slides when they get sent out afterwards, but I'll be able to copy a link into the chat. So any questions?
Thanks, Liam. So we've got a few questions in the question and answer function. So can I call on Tony Cox, please, who's asked all three actually, to ask this first question?
Hello, I hope you can hear me. I'm trying out a microphone. Thanks, Liam, for a very clear presentation. I've just got a few queries. Can you first of all clarify the variables you feed into your machine learning system? I wasn't quite clear if they were product label descriptions or observable features of the product in question, or a combination of the two, or maybe something else.
So we're using some fairly standard machine learning word embeddings. So that includes things like TF-IDF and fast text as word embeddings. But we're also using some custom features that we've created ourselves. So that would be kind of searching the text for words such as kind of women's or boys, or things like that, to determine the age and gender that the product is aimed towards, which is an important aspect of our class. So it's a mixture of standard word embeddings and some custom features that we've created ourselves.
Tony, do you want to ask your second question?
Yeah, if I could. Yeah, thanks for that, Liam. Yeah, will that detail be in the papers that you referred to? That's one point on that. But my second question is, once established, once you've got the machine learning system working okay, will you come back to it periodically to make sure that it's still doing what you expect of it? I'm just thinking of a possible situation in which, I mean, clothing in particular changes quite a bit over time. So I'm just wondering if your machine learning will be able to keep up to date, and how you'll check that it is keeping up to date.
Yeah, so there will be more detail on the features in the paper. In fact, I think it links to an earlier, more methodological paper that discusses our features in a bit more detail. In terms of kind of keeping it up to date, we are going to track performance over time to ensure that the performance isn't dropping too much, but we can retrain the model as we label data in the future to ensure that it keeps up to date. So yeah, we will track the kind of changing nature of clothing.
Thanks for that. Shall I ask my third question?
Yeah, and then Tony,
Yeah.
and then we've got Dave B waiting with a question about clustering after
Okay,
Tony.
great. Yeah, my last question was just to confirm, it looked like it from your slide, just to confirm though that you're investigating all three basic aggregation formula, i.e. Jevons, Juto and Carly.
Yes, so we've assessed them against the framework. So we have scored them. So yes, we are assessing all three, as well as a range of other methods for use when we've got weighted data sources, for example.
Brilliant. Thanks very much for that. I mean, very clear.
Thanks, Tony. Can I call on Dave B, please, to ask your question?
Yeah, thanks very much. So actually, just quickly building off your response to Tony's question, I wonder if you've considered image embedding. So the folks at Amazon, Bayeri and Chernozhukov have some work on this where they found that embedding of images associated with products are quite useful, particularly for clothing. And then the question about clustering, it seems like a sensible sort of second best solution if you maintain the assumption, I guess, that the folks who are paying the high prices when the products appear are different in some sense from the folks who buy them later. So particularly with fashion, that makes sense. But I'm wondering what your thinking is, what your sort of justification is for smoothing through those things from that perspective. I could imagine, you wouldn't want to treat early adopters and late adopters the same. On the other hand, particularly with high-tech goods, as you mentioned early in your presentation, sometimes incumbent goods can move sympathetically as new goods enter and the prices are driven down because of competition, and you might want to use say a class mean change to impute the price as the product enters, as is done with some CPIs in different places around the world. Thanks.
Sorry, can you repeat the first question?
I'm sorry, repeat the second question.
Repeat the first question, please.
The first question was about embedding. So you
yes.
said you were embedding the descriptions. I don't know whether you have access to images, but the Bayeri and Chernozhukov at Amazon found that embedding images was very useful for clothing as well.
Images are a challenging aspect just because there's kind of copyright associated with it. So there's kind of an ethical decision that I guess needs to be made there in terms of whether it's appropriate to scrape images. So at the minute we are focusing on text, and we're getting reasonable results with the kind of text approach. But like ideally, if in the future we can do images, it's a point that we need to consider in the future, I guess. And sorry, I just the second question. Can you repeat that again, please?
So your smoothing approach or your clustering to eliminate the churn that you mentioned when you were showing the sort of price cascade from the forced substitution of new products. I mean, I guess I'm wondering how you're thinking about how you're treating quality there. If it's the case that the new product entering is driving the price of the incumbent product down through the sort of law of one quality adjusted price, if you will, then you wouldn't want to do that kind of smoothing. On the other hand, if you're concerned about folks who buy these goods when they first appear as being distinct in some important way from folks who buy them when they're no longer fashionable, then it seems like your smoothing would be doing something constructive.
Liam, it might be worth following this one up
Yeah,
offline, because we've got to move on to the next presentation. Sorry, Dave, but can we follow that one up, perhaps via email?
yeah.
Yes, of course.
Yeah.
I've saved my email here, so you can contact me, and anyone can.
So sorry for others who have asked questions, but we're going to have to move on to the second presentation now. So can I ask Heidi to start sharing her slides, please?
Good afternoon. Can everyone see the slides?
Yeah, we can see them.
Excellent. Well, thank you very much, Chris, and good afternoon, everyone. First, I'd just like to thank the ONS for inviting me and Statistics Canada to participate in this session. It's always interesting and a pleasure to collaborate with our peer institutions and also to learn from the experiences of the organizations such as Eurostat. So today I'd like to share the experience of the Canadian CPI in terms of implementing alternative data sources. This is year 3 of our 5-year CPI modernization plan. We certainly did not anticipate having to deal with a pandemic situation during this transition. But what I would like to do is just provide a bit of background on what we're doing, why we're doing it, and then illustrate the how using the clothing example. I should introduce myself, I guess. I'm the director of the Consumer Prices Division at Statistics Canada. Relatively new. I've been in the division for a year, but acting as the director for just a few months. So a lot of the material you're going to see this afternoon is technical, coming from my technical team. And if I can't answer questions afterwards, I'll be happy to put you in contact with that team. So the use of alternative data sources is not new to Statistics Canada. Administrative data such as tax, customs, and other records from the provinces and territories have been used in whole or in part in nearly half of our statistical programs for some time. However, as part of the agency's modernization plan, we continue to seek opportunities to increase the use of administrative data and to maximize access and use to alternative data sources. And this, of course, is to reduce response burden, to lower costs, improve quality, and offer new data series for the users. So as the use of alternative data increases, you can see that field collection or traditional collection and the costs associated with that collection decrease. And for us in Canada, that allows us to reinvest those savings into new pipelines, new processes, and new methods, as well as new skills and people in terms of the workforce to modernize the CPI. So the vision is really to increase the use of alternative data sources for more efficient and relevant CPI, to simplify the processing systems to be more adaptable, scalable, and easier to use, and to develop a data depot to increase data accessibility and interpretability and facilitate analysis. And finally, to be able to start producing experimental series and alternative data products, which we can't do with field collection. So this is just an overview of the modernization plan. It's split into 2 phases. The first phase is years 1 to 3. So we are now currently in year 3. The first 3 years, the goal was to replace 50% of existing collected prices with alternative data sources. And you can see in the chart there the proportion by commodity class. And so, as I said, we're in the final year of this first phase. So by the end of March, we will have 50% of our collected prices coming from alternative data sources, representing 20% of the CPI basket weight. The phase 2, I guess, that we're calling years 4 and 5 is really to maximize the use of all the data. So the objective is to increase the number of prices coming from ADS, use all the data, and in parallel, continue with the research into the methods and processes for machine learning and multilateral price indexes. And sample augmentation is always happening in the background. So by the end of March 2023, the goal is to have between 70 and 80% of collected prices coming from ADS, representing 55% of the basket weight. I should mention, actually, in the context of the pandemic, that the fact that we have alternative data in the CPI already was really key during the period where field collection or traditional collection was interrupted. It's actually still interrupted in Canada. So the fact that we already have almost half of our prices coming from alternative data ensured a fairly smooth, continuous and accurate CPI. So we're very pleased that we had embarked already on this modernization plan. There was no interruption to any of our ADS coming in, including scanner and web scraping. So here you can see just the different types of ADS that we have already in use. For scanner data, it's only for the food retailers at this point. We have 3 main retailers, or large retailers. And of course, with this, we get prices, characteristics, and quantities. So it's a very rich data source. For web scraping, we're doing a lot of web scraping for many different types of products and commodities, but in production, we are only using clothing at the moment. We have 3 Canadian clothing retailers in the CPI, and again, here we get prices and characteristics. We have application programming interfaces for hotels, flights, and package holidays, and we have other types of ADS that are acquired from third-party providers. This, for example, is for gasoline, electronics, and insurance data. And finally, just an overview of our progress dashboard in terms of implementation of ADS against the modernization goals that I noted earlier. So every month we have approximately 109,000 prices going into the CPI. So half of that would be 54,000. So we're currently at 49,000 prices coming from ADS. So we're almost at our 50% goal. You can see the trend over time in terms of reducing field collection and increasing ADS. And the third column on the right can show you then the breakout, the different types of ADS for the different commodity groups. So you can see food largely coming from the scanner data now, the clothing, web scraping representing about 21% of those prices. And the caps in orange, of course, is our traditional collection. So if we turn to the particular case of clothing, the clothing price index currently represents about 5% of the CPI basket. And prior to the introduction of web scrape data, it accounted for 12% of field collection. It also represents 21% of the elementary aggregates. So given the basket weight in the CPI, we were allocating a disproportionate amount of resources and effort to collect clothing prices, to doing the quality adjustment and all the processing compared to other CPI components. So this in large part was the motivation for turning to web scrape data for clothing. Of course, as Liam has already alluded to, you know, there are some challenges in terms of substitution, product churn, seasonality, and all of that. And then I noted the quality adjustment as a resource-intensive activity for clothing in terms of matching from month to month. So of course, the benefits of moving to web scrape was first to reduce response burden, of course, but we also now acquire a much larger volume of information at greater frequency and in a much more cost-effective manner. The other issue is that as Canadians are purchasing more and more online, we wanted to have that reflected in the CPI. So the fact that we're collecting some of our prices now online does reflect the purchasing patterns of the consumers. So bringing the web scrape data into the CPI means a new approach was needed. Oops. So we have broken up our implementation into the short-term plan, which is actually already happening, and then a medium to long-term plan. So we are taking a gradual approach to implementing the web scrape data into production. Instead of waiting for all the data and the methods to be fully automated, we are implementing data into CPI production according to the short-term, medium, and long-term plan. So the top process flow that you can see in the slide is the short-term plan, which represents what we've already done, which is to combine weekly web scrape data with field collected data. We have currently 3 online retailers integrated into production, and that started with the January 2020 reference month. The 3 retailers represent 6% of the clothing market share and about 10% of clothing field collection. And the objective here was to get used to ingesting, classifying, and analyzing large amounts of web scrape data. Similar to the ONS, machine learning is used to classify the data at the EA level, and the data are then aggregated using a geometric mean and combined with prices from traditional collection. The process flow in the middle is the research work we're doing in parallel. So behind all of the plans and implementation, we are conducting research similar to the ONS, using machine learning to group specific products into product groups or clusters, and then experimenting with bilateral, multilateral indexes at cluster levels and EA levels to select the best option for production. And that will then bring us to the medium and long term. The medium term is to start introducing clustering techniques into the production process. And once this is in place, we will continue to introduce more online retailers and further reduce field collection. So in the short-term plan, the first step was to classify the raw web scrape data. And this was done by selecting, again, a small proportion of the raw data, manually assigning the products to the CPI EAs to create the training data set. Similar to the ONS, there was supervised machine learning classifiers, such as random forest, used to assign the products to the CPI. So I won't go into too much detail here. This is quite similar to what the ONS is currently doing. And it is a resource intensive activity in terms of creating the training database. It does require a lot of testing and validation to make sure that the classifier actually learned the pattern instead of remembering it. And we do, just noting the question that came up after the last presentation, we do do quality assurance and checks to those machine learning algorithms. For clustering, this is more for now the medium and longer term, so this is not yet being done in production, but we are certainly making progress in our research. We are exploring methods that are probably known to most of you already and in use at other statistical agencies. So from a classification approach, we're using machine learning to classify products into homogeneous product groups or clusters, as I mentioned. This is the CLIP method from the ONS, and so that's clustering large data sets into price indices. The second approach that we're looking at is based on quality adjustment. So the products are being classified according to their price and the degree of product match. This is known as the MARS method, the matched adjusted R squared measure, and this is being used by the Netherlands. And of course, there's the combination of the two, combining the classification and the quality adjustment.
That's just under 5 minutes left, Heidi.
Thank you. So we have proposed that we will combine both the CLIP and the MARS methods in terms of moving ahead for clustering. So this outlines sort of our steps, determining the clusters for the base month by looking at both prices and attributes from the product description. And then MARS and some other measures would be used to optimize the clustering process. And then, of course, we would assign products in each time period to the defined clusters using a decision tree machine learning model. And then we move on to index calculation. So it just gives you a bit of a flavor of the research that we're working on and the experimentation that we're doing. And I'll just show you our pipeline, which shows you the different steps from web scrape raw to the classification and then to the clustering. So in terms of challenges with web scrape data in production, obviously there's challenges in terms of acquiring the data. We are actually using a third party to web scrape for us. Websites change, the data presented on each website may be different, so that is challenging. So the expertise lies with the third party provider who is doing this for us. Of course, the data is less structured than scanner data. We have, an issue between national pricing versus province specific. So we do produce CPIs at province, territory, and city level. So when you move to web scrape data, you're typically getting a national price, which can cause some complexity. And then, of course, there are always some differences between online and offline offerings. In terms of implementation, there were some challenges in just combining the prices from the different data sources and using the different methods. Of course, we don't have any quantity information, so we have to use a proxy of product offers for the weight. And again, maintenance in terms of how often to update the clusters. So I'll just show you, there are a few slides here to demonstrate basically how we tested all of this. This is for the short-term implementation. So prior to actually implementing web scrape data in January of 2020, we were collecting already data for some time since 2018. So we were able to sort of do some backcasting, some testing, and of course, some parallel runs before we actually implemented the data. So you can see that the trend there in the all items is almost identical, no real impact. This is for the clothing and footwear price index itself. Again, trends are very similar. There's a half index point difference observed in July 2018. That was due to an increase in sale and clearance prices from online data due to end of season sale. But again, it all looks very robust. And this is the index, and you can see where we actually implemented the web scrape data. You can also see here, interestingly, the impact of the pandemic in March, April, May, and June. So very quickly, I'll just end with some considerations. In terms of the scope of the CPI, obviously right now our CPI is measuring domestic retailers and prices. As you know, consumers are increasingly purchasing online and from third-party platforms and international retailers, we may consider revisiting the scope. Another consideration is that the data acquisition process and the web scraping process are not always straightforward and not without cost and effort. So there still are costs, there still is a lot of work. So it's not one-for-one replace field collection with ADS. There's always other issues and costs and efforts to take into account. Of course, the quality of the CPI is always our top priority, which is why we've adopted a cautious and gradual implementation to mitigate the risk of any error and to keep our users informed in advance of changes to the data sources and the methodologies. So whenever we do introduce new data source or methods, we put out a technical paper and communicate that change ahead of time to users. I've linked here the paper that went out when we did introduce the 3 online clothing retailers using web scrape. And I've also linked here the CPI portal that we launched last year, which is your one-stop shop to all information and data for the Canadian CPI. So I'll leave it there and take any questions.
Thanks very much, Heidi. So there are no questions in the QA at the moment. Does anyone want to raise a question for Heidi?
I guess it was either really clear or people are going to bombard me after with questions, but I'm happy to take questions. My email address is on the title slide.
Okay, we'll just give it another minute or two, Heidi, to see if anything comes through on the Q&A. Okay, so can I ask Sumit, please, to ask your question?
Hi there, Heidi. Thanks so much for that talk. That was really interesting. I just want to pick up on, I think it's one of your final slides there around the experience around the implementation, and you kind of spoke about your engagement with users. So I was just wondering if you could share some of the lessons learned or the things you may have done differently in hindsight in terms of managing the kind of successful implementation. Because as you say, I think there can be sometimes a little bit of resistance when you kind of move from traditional to alternative ways of doing it. So I just wondered if there's any lessons learned you had for other NSIs kind of looking to do similar progress. Thank you so much.
Sure. Thanks so much for your question. Internally, the implementation was quite complex. Again, we launched right in with our scanner data. We didn't know what the scanner data was going to look like. Each retailer that was sending scanner data had a different set of data. It was not necessarily consistent in how it was being presented to us. And a lot of the work in the early days was manual. Then once we started introducing machine learning for classifying, it really helped us, and we gained experience internally in terms of how to manage the volume of data, how to do the classification. And now that we're up and running, it's working quite well. For web scrape data, we're still, I would say, in the early stages, which is why we've only started with the 3 clothing retailers in production. Similar challenges there. You know, there's people learning all the time in terms of, you know, how to again classify, and then once we add retailers, how are we going to aggregate and do the clustering. In terms of users, I would say, you know, we didn't get a whole lot of resistance. I think for the most part, given the, you know, the online presence, and a lot of purchasing happening using that that mode. You know, it made sense to have some of the prices in the CPI reflecting what Canadians are actually purchasing and how they're purchasing them. So we try to alert users to changes, you know, about 3 to 6 months in advance. We do technical briefings once we do the implementation, so we have an opportunity for people to ask those questions that they may need to understand for their own work and their own use of the CPI. So I think overall, you know, we're pleased that we went ahead and have done this, and we're pleased with the progress we've made, but it certainly wasn't without challenge and a lot of effort. And it's a huge team actually in Canada. We have 130 people working in the Consumer Prices Division, which I know is a lot compared to some other statistical agencies. But we do have to manage, you know, the transition from, you know, all field collection or traditional collection to the combination of ADS and traditional collection.
Thanks, Heidi. I think given that there's just under 30 minutes left, I might call that bit to a close now and ask Claude to start sharing your screen. There's one question that's not related to clothing that we can follow up on email if we so wish. But apologies, we can't ask that. So thank you, Heidi, and I'll ask Claude to start sharing.
Thank you.
So I hope that's showing well on the screen.
Yep, I can see it.
Yes. Yes, thank you, Chris. So good afternoon to everyone. My name is Claude Lamboray, and I'm working for Eurostat, which is the Statistical Office of the European Union in the Price Statistics Unit. And of course, I would also like to thank UNS for the invitation to be able to contribute to this session. And in my presentation, I would like to discuss how we are going to integrate eventually these new data sources into our CPI baskets, and what does that mean in terms of methodology. I would like to get back by recalling how CPIs are typically constructed and compiled. As most of you know, CPIs are organized according to some classification. In Europe, we use a classification which is called ESCoE. And the lowest level of that classification are 5-digit subclasses. Now, these subclasses are typically further subdivided into more specific product categories. In some countries, they are called items. And it's also common practice to further stratify these items, for example, according to region or according to type of outlet. And traditionally, the elementary aggregate is understood as being simply the smallest aggregate for which we have, or for which weights are used. Within an elementary aggregate, outlets are sampled and product offers are selected for pricing in these outlets. CPI data is essentially panel data, so we observe the prices for essentially the same product offers over time. Now, from an index compilation point of view, CPIs are compiled in 2 stages. So in the first stage, elementary indices are obtained using some kind of unweighted index formula. So very often the Jevons index is used with this, which is based on a geometric average. And in the second stage, these individual price indices are aggregated up to higher levels using some kind of fixed expenditure weights from the past. This is what we would call a kind of Laspert type index. Now, when an agency, statistical agency accesses new data sources, it looks very natural to simply treat the prices obtained from these new data sources in the same way as prices collected in the field and keep the methodology largely unchanged. And this is a very reasonable strategy. It has some practical advantages, and it's also safe from a methodological point of view. However, a more ambitious strategy would be to adjust this standard two-stage aggregation system to the new data sources. And there are very good reasons to do this. First of all, as we've seen, the new data sources often have a much wider coverage than our field price collection. So we have more products, more product varieties. Maybe we cover more outlets. We have a better coverage across time. And of course, we would like to take advantage of these increased coverages. Moreover, the new data sources are also typically characterized by being dynamic. So it means that products enter and exit our data sets all the time, which makes it a bit more difficult than working with a clean panel data set. And finally, weights may or may not be available at more detailed levels. And all of this implies that our data can now be stratified or structured and in different ways. And there's a large range of possible index compilation methods that we can use at the various stages. So I will focus now in my presentation on this second strategy. Now, when we integrate a new data source, the first question to ask is, at which level should the new data source be introduced? What do I mean by this? On the left-hand side, the new data source is integrated at ESCoE subclass level. So we have a subclass which is called garments for men. And that subclass is subdivided into two components, field collection and new data source. For field collection, we have items, let's say jackets and other things, and we compile our price index the usual way. And for the new data source, we also have to compile a price index using some kind of appropriate methodology. An alternative that's on the right-hand side would be to integrate the new data source at the lower level. So let's say at the item level. So we would have jackets, for instance, and we would subdivide jackets into two components. On the one hand, field collection, and on the other hand, new data sources. So integration at the item level is, of course, more consistent with what we've been doing in the past. There may be a specific user need to have a price index for, let's say, jackets, in which case we need to integrate the new data source at that level. That price index may even be published in some countries. On the other hand, integrating the new data source at the higher level, so let's say at the ESCoE subclass level, allows for more flexibility. For example, it may be that our new data source comes with a kind of classification which does not fully align on our traditional item structure, and we would like to work with this new classification of our data source. Now, in any case, we need to think about the data source as a stratum of our let's call it target universe, to which we need to assign a fixed weight, and for which a price index must be estimated. And an important question to ask here is already, what do these weights represent? For example, if we have a price index compiled with web scrape data, does that price index represent only purchases made online, or does it also cover purchases made in some physical stores? For example, we may have some stores with both an online and an offline presence, but we may only collect prices online. In that case, we need to adjust our weights upwards accordingly. Now, technically, what we are trying to do here is to come up with an overall price index which combines a price index for the new data source with a price index compiled in the field. So as we have seen, we have weights, which measure or which represent the importance of each data source. And from an index point of view, technically we have two options. We have many more options, of course, but there are two main options. We could simply apply a Lamboray type index. So that's an weighted arithmetic mean of price indices. Or alternatively, we could do a geometric Lamboray index, which is a weighted geometric average of price indices. And the choice matters actually, because it will have an impact on results. Numerically, the Lamboray index will always sit above a geometric Lamboray index. So in this case, maybe the most natural choice would be to use a traditional Lamboray aggregation, which would be consistent with what we are doing to come up with our higher level indices. But there may also be arguments in favor of using, let's say, geometric averaging, because that would be more consistent with, for example, a Jevons index that we typically apply at the lower levels. In fact, when you're looking at it, we are coming up here with a kind of multi-source price index that combines sub-indices based on different methodologies. On the one hand, we have scanner data, which is composed of, let's say, a census of transaction. We have prices and quantities, very rich data sets, which allows us to compile a price index of a very good quality. Probably a price index which is very close to some kind of target. With web scrape data, we also still have some large data sets. We have a good coverage, but it may still be some bias because of the lack of weights. And finally, our prices collected in the fields. We have smaller data sets, which are typically the result of some kind of multi-stage sampling, complicated sampling designs that include non-probability sampling methods to a large extent. And an open question here is, can the weight allocation between data sources be optimized, taking into account the quality of each data source? So what do I mean by the quality of each data source, and how can we measure it? Well, with price collection in the field, we do have some, let's say, sampling error. With field price collection and web scrape data, we may have some elementary aggregate bias. And maybe just like with optimizing a mean square error, can we find here a kind of optimum between bias and variance? In fact, trivially, if price collection in the field has more or less the same price dynamics than scanner data, then we could simply drop our field price collection. Now, there's another interesting, let's say, side effect here. Very often what happens is that the prices that we now obtain from new data sources have been previously obtained in field price collection. And this now implies that our samples for the field price collection, our sample sizes for the field price collection will go down. Now that may not necessarily be a problem. But there can still be a need to rethink our price index for prices collected in the field. We may need to have another look at our sampling strategy. We may need to add more products maybe, or more outlets, or we may compile our elementary aggregates somehow differently. Now, when we're looking at the new data source, a key question is, what is actually the product that we would like to follow? So what is this statistical unit for which we are tracking prices? Traditionally, we are actually observing product offers, which is simply the price of a specific product in a specific outlet at a specific time. But as we have now seen already in our previous presentations, let's say with web scrape data, we may not only have one price quote per month, but maybe a price quote per week or per day or even per hour. So we need to do some aggregation across time. We may also want to aggregate across outlets, for instance, outlets that belong to the same retail chain or websites that sell the same models. And finally, we may also want to do some kind of aggregation across item codes that have a similar quality. And the result of this aggregation is what we would call now an homogeneous product. So when we are constructing these homogeneous products, we need to consider the 3 dimensions: time, outlet, and product. And the basic idea here is to assume no quality differences between the product offers that are grouped together. So quality differences have to be evaluated here with respect to these 3 dimensions: time, time of purchase, place of purchase, and product attributes. And why are we doing this actually? We are doing this to improve matching over time. Let's take an example. We could say that our product are simply t-shirts. So that's good because a t-shirt will always be available over time. So that's easy to track. But maybe we have t-shirts of different qualities. So that's not such a good idea. And we want to define our product a bit more tightly. So we could say our product are t-shirts, short sleeves, cotton fabric. We could even go one step further and say our product are simply item codes, is simply an item code of a specific t-shirt. Now the problem with that approach is that this item code may only be available during certain months and then disappears from the market, so that's not very stable. So the whole point here is to find a compromise between, on the one hand, homogeneity and avoid unit value bias, and on the other hand, increased matching over time. And this is especially relevant for clothing, where we have, as we've seen in the previous presentations, large synchronized assortment changes, especially at the end of a season. And clothing is also a product where we have, where we can more or less easily come up with some kind of standardized product features. Now that's the theory, of course, because in practice we need to have the metadata to construct this kind of homogeneous products, and the information must be extracted from text strings, or maybe we are lucky and have some more structured product characteristics available in our data source. In any case, the specification of the homogeneous product is really critical and can significantly impact our end results. Now, how can we now design a price index from web scraped with web scraped data? Well, it all starts with an individual price observation. So that's a price, let's say, for a specific jacket at a specific date on a specific website. And as previously discussed, we may not only have one price quote, but several price quotes per month, and we may want to group our product offers into some kind of homogeneous product according to some product attributes. And technically, how can we do this? Well, we simply compile either an arithmetic or a geometric average of price quotes. So with web scrape data, usually we do not have any information on weights. So the only thing we can do is some kind of unweighted averaging. Now at the next level,
just under 5 minutes, sorry, Claude.
Yes, sorry. Thanks, Chris. So at the next level, we have a product category, which is called, let's say, jackets. So we want to combine our homogeneous products into a price index for jackets. And there are many choices to do this. There are bilateral indices, there are multilateral indices. It also depends if weights are or are not available. So typically with web scrape data, weights are not available, but we may try to come up with some kind of proxy weights using, for example, the value of the scraped data. As we've also seen in the ONS presentation, with bilateral indices, we need to make a decision if the index is applied in a chain form or if it's a fixed base index. We have multilateral options. Now, multilateral price indices work best with weights, but they can also be applied without weights. And there are some technical choices to be made regarding, for example, window length, or splicing method. Now let's assume we do not have web scrape data, but scanner data, transaction data. The big advantage of scanner data is that we have quantities at the item code level, which allows us to compile proper unit value price indices. So that's a true average price. So conceptually, for a truly homogeneous product, the unit value price would be our preferred target. So this does not exempt us from defining these homogeneous products, but conditional on a homogeneous product definition, proper unit values can be calculated. Now at the next level, let's say jackets, our preferred approach would be to apply some kind of multilateral method. Multilateral methods have the advantage that they take into account the weights, they cope well with the dynamic product universe, and they do not have some of the disadvantages that come with, let's say, bilateral chained indices. And then we may want to combine the different product categories into product category indices into an index, let's say for a retailer. Again, the most natural way to do it would be to apply a Laspère type index at this level. In fact, we now think of an elementary aggregate as being the smallest aggregate used in a Laspère type index. So in this example, our elementary aggregates would be jackets, trousers, and other product categories. And this is really something important because the elementary aggregate is now the frontier where we switch from a, let's say, a variable weights approach to a fixed weight approach. So it's the level where we switch from a multilateral index formula to a Laspère type index formula. And when you think about it, instead of using a Laspère type index, you could also use at this level a geometric Laspère index. In fact, as we're working with scanner data, we may have very good information on weights, so we could even apply a Törnqvist index, which is a symmetrically weighted price index formula. Now, again, using a geometric Laspère or Törnqvist instead of a Laspère type index will have the impact of pushing our inflation figures down, or the other way around, pushing down the level where we first apply our Laspère type formula will have an upward impact on our inflation measurement. There's even another alternative, which would be to skip the product category altogether and apply the multilateral method at a higher level. So we would simply have a price index for, let's say, garments for men for a specific retailer. So that's the most flexible solution, which would cope well with any changes in the assortment or sales structure of that retailer. So my message here is to say that new data sources should and will lead to new aggregation structures in our CPIs. We should think about different data sources as being different strata of our universe, and we need to assign weights to them, and we need to compile a best possible price index. With web scrape data and scanner data, we have to think about what's the product, what's the homogeneous product. We have to think about what are the different levels for which we compile indices. We need to be aware that different index formulas can be used at different stages of aggregation. And all these, I call it structural decision, can have an impact on our inflation measurements. So I think that's the end of my presentation. Sorry if I took 1 or 2 minutes more, and yeah, I'm happy to take some questions.
Thank you very much, Claude. So we'll open the floor to questions. There's nothing in the Q&A box at the moment. So does anyone have any questions they want to raise? So there's nothing coming through at the moment, but there was one question for Heidi, which Heidi's said she's happy to answer while we're waiting. So perhaps can we ask Tony Cox to ask the question about the API?
Sure. Yeah, my question to Heidi was regarding the APIs that she referred to in one of her slides. And she said that we can collect information from travel companies on that. And I just wondered why the weighting, the slide also indicated weighting information wasn't available. And I wondered why not, since I'd have thought that the API would give access to that information as well.
Thanks for the question, Tony. Yeah, in fact, we don't get any weight information through the API. So we're getting all the product offers. So in the case of airline, for example, we're getting, you know, on a daily basis, the different trips, I guess, destinations, city destinations, and available pricing, but we don't actually have any information about the quantity being purchased. And the weights are coming from our spending survey and an air exit survey that's done within StatsCan. So I'm happy to you know, get some more information if you're still curious, but yeah, the only weights we get from our ADS is through the actual scanner data.
Okay, thanks. I do have a question for Claude. I can't get the Q&A up on my screen for some reason. Can I ask that?
Yes, so there's, if you can ask the question, Tony, then there's one final one from Sumit, I think.
Okay, just quickly then, given that inflation is a latent variable, so we don't actually know the true value ever, I just wondered how we, and you referred to different aggregation methods giving different results at the various different levels. How do we go about choosing between them?
Yes, well, first of all, thanks a lot for this question. And that's exactly, I think, one of the challenging aspects that we face with let's say, price measurement, that our target is not always known. But I think there are a number of issues. What I can say on this is, first of all, we should be aware of these various options to calculate our indices, and we can at least empirically find out what will be the difference if we apply one or the other method. Another, I would say, strategy is to think about what would be maybe our target index. So what would be our, let's say, at least theoretical ideal value which we would like to measure, and how can we best now approach that target value. But again, there may be no consensus on what that ideal should be. So yes, this is a challenging problem, and I think with the new data sources it becomes even more complicated than what we're used to in the past, when we were discussing, for example, the choice of different index formulas at the elementary level, Jevons, Dutour, or let's say Carly, for example.
Thank you. So we've got just over 2 minutes left. Sumit, do you want to quickly ask your final question?
Thanks very much, Claude, for that. So I don't know if you could hear me there. So I was just saying that both you and Liam spoke about the trade-off between the homogeneity and the matching of products. And I was just wondering if you had any views on whether you think that will become more challenging over time as product churn might increase. And if you do think it will become more of a challenge, do you have any views on how you best manage that trade-off? Thank you very much.
Should I?
Yeah, please.
Yeah, okay. Well, maybe it's the case it will become more challenging, that I do not know. But what I can say is that, first of all, on the trade-off between homogeneity and matching, we should not make, of course, the arrow and try to construct too broad products, which would lead to some kind of unit value bias. So for the two objectives, my personal opinion is to be careful, at least with the not to over, let's say, stretch our homogeneity principle. On top of it, well, there are some methods which has also been mentioned in this presentation. I think it was on Heidi's slides. There is a method which is called MAS, which has been developed by, I think, Statistics Netherlands, Tony Chessa, which helps you to some kind of numerically, at least for a given data set, to find a kind of optimum between these two objectives. And finally, I would say that there is another, maybe there are also other strategies which we should explore, maybe not so much for clothing, but let's say in the case of consumer electronics, which would be to work with hedonic approaches, or so explicit quality adjustment methods, which could also do the trick, if I wish to say so.
Thanks, Claude. And I think that just about wraps up our time. So I just want to say thank you very much to Heidi, to Claude, and to Liam for taking the time to present today. And then finally, thanks to all the participants for taking the time to join us. And I bid everyone a good weekend, and thanks again.